Good evening. Welcome back to another Provident webinar. I'm your host, Ed Mann, Director of Training and Education for Provident. Tonight, I have the pleasure of introducing Bobby Schneider from the Energy Security Agency to provide you with some valuable information about the challenges and solutions for dealing with incidents related to electric vehicles. Now, before we go any further, I'm going to give it a minute or two because we have a lot of people joining us tonight, and I don't want to cheat anybody. As I sit here and watch participants, the numbers are jumping 4 and 5 at a time. So just be patient. And when I see the numbers level off on people joining us, I'll get back into it. We're still climbing. We haven't leveled off yet, folks. Still climbing. I'm going to give it another minute, and then we're going to jump in. Those that join us late can catch up. Okay, we've leveled off at 470. Now we're at 472. We're going to jump in. Before I go too far, I want to add a disclaimer to tonight's program. Tonight should not be the only training you participate in related to electric vehicles, lithium-ion batteries. I say this because I've had over 100 hours of training through a variety of sources, and every time I think I'm on top of my game, I learn something new and realize I don't know as much as I thought. Bobby will introduce himself in a few moments, but before we're going to cover a couple of housekeeping issues for our listeners. We will post a post-webinar email tomorrow with a recording of this webinar. Any links we mentioned tonight will be included in that email. In a separate email, you'll receive a certificate of attendance from me. Please check your spam folders before sending me an email indicating that you have not received your certificate. Please note the name and email address you used to register will be used to create the certificate. So if you put a phony name in the registration and get a certificate with a phony name, it's not my fault. It's you put a phony name in the registration. For those hosting a webinar screening at your department, please send an Excel spreadsheet to info@providentins.com or to me, eman@providentins.com, with the first name, last name, and the email address of each attendee. It makes it a lot easier for me to copy and paste it from a spreadsheet into another spreadsheet if I have everything in a spreadsheet. So this is part of our Provident webinar series. And as usual, we cover a little information about what Provident is or who Provident is. Provident got started in 1902 as an independent insurance agency in the Pittsburgh area. In 1928, they began serving volunteer fire departments with customized blanket and accident health policy. Today, we provide volunteer combination career firefighters, emergency medical responders with a multitude of insurance programs. We also now offer insurance programs to law enforcement, and we have some special risk policies. Provident celebrating its 6th year in a row as one of the top insurance employers by the Insurance Business Magazine. So some of the things that we offer to emergency services are accident and health insurance, and our 24-hour accidental death and dismemberment insurance, a group term life, critical illness and cancer, and our Fire Plus property and casualty insurance. So I want to focus on the accident and health insurance for a minute. The accident and health insurance is a policy that we offer to emergency services organization to provide protection to your members if they get hurt while they're doing something on behalf of your organization. And if you are an accident and health client, your members and your immediate family members have access to our first responder assistance program. If you're a property and casualty client, your department has free access to our Fire Plus Academy, which is through Fire Rescue One with over 800 courses available. I want to remind everybody that on March the 26th at 7 p.m., we'll be doing a webinar with Alec Mayer from CDC NIOSH to talk about the National Firefighter Registry for Cancer. And I'm hoping we have as many people join us for that as we did tonight, because the bottom line is get registered in the National Registry, and you can learn more about it that night. Tonight, as I said, we have Bobby Schneider going to cover electric vehicles and challenges and solutions. He's the Director of Training and Education for the Energy Security Agency. And I'm going to stop sharing my computer and let Bobby tell you about himself. Bobby, it's all you.
All right. Good evening, everybody. Thanks for logging in. I'd like to thank Ed and Provident for hosting this and inviting myself and our organization to come and present some information this evening. And also to Sam, who's running some things behind the scene here that's partnering up there with Ed. Let me give everybody a brief overview. I wish I could be in front of all of you and see all your faces. But we'll work through this technology that we've got going on here. Again, so my name is Bobby Schneider. I am the Director of Training and Education for the Energy Security Agency. I'm going to get into who the ESA is here in a few minutes, but let me give you a little bit of background on myself. I am a 20-year career firefighter. I work for a suburb of the city of Columbus. I'm a lieutenant on the engine rescue there. My department has 4 stations. We take about 13,000 runs a year. We have a little bit over 100 full-time firefighter, paramedics. And then myself, I am also a paramedic, EMS instructor, fire instructor. I did a few years as a flight medic. And then also in tech rescue, I'm a rescue technician. I was on Ohio Task Force 1 for 12 years. I'm a team leader on a regional water asset, Type 1, that we deploy through EMAC agreements, and heavily involved in the rescue side as well. And that's how kind of collectively we came into being the ESA. So let me share my screen here and we will get going. Okay. So let's go back about 10 years ago. And we collectively, our group, for the past 16 years, we run and operate a tech rescue training company called Rescue Methods. Rescue Methods is centralized and located in Central Ohio, but we teach tech rescue disciplines across the state, across the United States. We're fortunate enough to go to Australia and do swiftwater training for the Australians in Australia. So over the past 16 years, we've delved heavily into all the tech rescue disciplines, teaching, competitions. We were competed in the first Grip Day that here in LA back a few years ago, and a handful of other competitions and things like that. Well, about 10 years ago, let's get into the fixed energy side real quick. About 10 years ago, there was incentivizing programs that were being put out through the government to have people come off the grid, whether it was residential homeowners, industry, municipalities to supplement the power grid. And these energy systems, same chemistries, lithium ion batteries that are in the current vehicles today, and these were popping up like crazy. California, New York, and a developer wanted to build a multi-story residential complex in Manhattan and wanted to install a fixed energy system as the backup for the structure for the building and put it in the sub level of the building. And FDNY, being the big machine that it is, was able to come in and say, stop. What happens if the batteries or the energy system has an incident? What would happen to the building? What happens if the building has an incident? What's it going to do with the battery system? And at that time, the only testing that had been done was, at least for the most part, cellular level testing. So that's where you would take 5, 10 cells, and you do something to make the cells go into a thermal event, thermal runaway. And then you look at the off gassing, the fire behavior. And then using mapping and modeling, you say, well, if 10 cells would do this and perform like this and react like this, then theoretically 30, 40, 50,000 cells in a system would react like this. Well, we are in a profession that theory and reality don't always line up. FDNY, again, in their wisdom, was like unacceptable. So at that point, things slowed down. And basically, and as an overview, they came in and said that any battery system that was going to be used in the state of New York would have to be subjected to large scale destructive testing to understand the systems. And they that was a joint project that was FDNY, state of New York, New York City, NYSERDA, Con Edison, and they hired a company called DNVGL. DNVGL is still in existence today, and they are involved with pretty much anything globally having to do with energy. They do certification testing and many other things. And so they hired DNVGL to perform these tests on all these battery systems. And it just so happened that the lead engineer for that project was a graduate of the Ohio State University, and he was from Ohio. His dad was a firefighter down in Southern Ohio, and through mutual acquaintances, he basically reached out to our COO, Dalen Zartman, and founder of Rescue Methods, and said, hey, we're going to be doing some testing on a large scale over the next year and a half in New York, and we're going to burn batteries, and we want you guys to be our fire guys and gals. And like any good firefighter, Dalen said, absolutely, we're in. And that began our crash course in batteries and battery systems. Over that next year and a half, back and forth to New York doing the testing. Those results came out. I'll make sure that I share with Ed that he can put out in a link those results from that initial test, looking back about 8 years ago now when they were posted. And at that point, once that test was over, that lead engineer, Nick Warner, he left DNVGL and created his own company called ESRG, Energy Safety Response Group. And at that time, we partnered with him. And for about the past 8 years, we run and operate arguably one of the world's largest large-scale destructive battery test site. So on a weekly basis over the past 8 years, myself, everybody involved with our organization, partnering with the SRG, will do certification testing for the fixed energy side. We will do testing for clients, looking at testing agents. We do ballistic testing, military testing, maritime system testing and oversight. And we have tested and burnt upwards and greater of 4 megawatt systems. So I would argue that there's probably not another group of individuals who happen to all be, besides our engineers on our side, all firefighters, all rescue technicians, probably not another group of individuals that have more exposure to lithium ion batteries in from a cellular to a modular to a full EV battery pack to a full fixed energy connect system when they're doing bad things. And then managing those and learning over the past 8 years what works, what doesn't work, and trying to share that information out as we started our educational component of the Energy Security Agency to share what we've learned and what works and what doesn't work, and overall to make everybody be able to safely and knowledgeably interact with these systems. So as I go through this, I got a little PowerPoint slide together. I've extracted some slides from our presentation. We offer awareness classes that can go typically about 4 to 5 hours of content. An operations class has some hands-on, but it can push about 7, 8 hours. So there's no way I'm going to be able to cover all of the material. So I'm going to hit some main points. And then if there's any major question that Ed, as he's filtering through questions that come through, he may jump in. Or when we get to the end, we'll start having a question and answer. And hopefully I can answer any and every question that pops up. And we'll see where we go from there. So yeah, so that's an overview of who we are, ESA. And so out of that, I'll get into a little bit more of how actually the ESA was created, but it's all the same group of individuals as that we started from the rescue methods. So a couple other things just to put out here. Not only do we do as an organization, one of the main things that we do, and I'll get into a little bit, we run and operate a response center that is manned by a full-time firefighter rescue technician, 24 hours a day, 7 days a week, for any stakeholder that is involved with an incident involving lithium-ion batteries, from tow and recovery, law enforcement, fire department, municipalities, OEMs, transportation incidents on our roadways. So anything and everything having to do with lithium-ion batteries and alternative energy systems, we run a 24/7 call center. So you think Chemtrek for hazmat, think poison control for overdoses. We are that for lithium-ion batteries and battery systems. So we run the call center. We do training for, we're heavily involved with tow and recovery, obviously with the fire service and training there. We do tow and recovery training, heavily involved with ISRI, which is the recycling and dismantling world. We do fleet services and oversee large fleets and managing and how to store and manage EV fleets. We work with OEMs. We contract and write ERGs for a handful of the OEMs, involved with service and collision centers. And then we also do real-time response. So when maybe less so on an EV, a lot of times we can help manage those incidents through our phones, our call center with the entities that are on scene. But when you have situations like the transportation of end of life batteries or DDR, damaged, defective, and recalled, you've probably seen on the news, whether it's locally or nationally, but there are a multitude of incidents where they have events in the transportation of these. We do real-time scene response to oversee those, and then also on the fixed energy side, we do response there to manage and mitigate the breakdown and packing and shipment to recyclers through our organization. So just a quick overview. In 2023, we responded to 10 major incidents. We have a specific federal DOT special permit that allows us a lot of allowances. So we work with a handful of environmental partners that are strategically located across the United States to do real-time response when we have one of those roadway incidents. And then they work under our special permit, and it allows collectively everyone to manage and mitigate the event fast and efficiently, and to get things back, roadways back open, and things needing to go where they need to go. Heavily involved with Waymo, the Mawasa lot. We over the past couple of years, we've been to Qatar. We went over and managed their electric bus fleet that they purchased prior to the World Cup. and then set up their charging stations, emergency response plans, training for their infrastructure on how to manage those buses if they were to have an event. In 2023, we did over 100 educational classes and conferences. Testing, just in 2023 alone, we did testing for organizations over 7 countries and 30 plus large scale tests. We also were awarded the NFPA, well, the FEMA grant. It is us, NFPA, and ESRG, and we are going to task to do the first large scale or full scale EV suppression study. So what that means is over the next year and a half, we will look at all the different suppression tools, the agents. We will test all of them through our lab, and then those results will be shared with NFPA, and they will put out this is best practice for suppression of EV fires. So we're excited about that. As I get in today, the great thing about that is we're going to be able to share all those results. A lot of what we do, almost all of what we do at our lab is NDA because we're testing for clients. But throughout tonight's podcast or thing here, I'm going to get into some suppression stuff. I won't be able to name specific agents, but I'm going to go over the concept of what we're looking at without disclosing any specific information, and then that will help give you the idea of what works and what doesn't work currently from our experience. So that's just an overview there. So let's get in here. And I know that we really don't have a response back like we do in real time, but one of the challenges. So let's take this incident here. This is an all-electric vehicle. This happened about coming up on a year ago in the spring. We managed this through our call center, and this vehicle was in upstate New York. It had gotten in an accident. The only damage you see is on that front driver's side area on the panel there. No other hidden damage. The battery pack was intact. It didn't have any damage, and that's the only damage. So that vehicle was not totaled. It was towed back to the tow yard, and then the next day it was dropped off at the local collision center that was going to do the repair, and was dropped off in the late afternoon, early evening in the yard. We got a call the next day to our call center from Lucid, saying, because we're heavily involved with Lucid, we've written the ERGs for their Lucid Air, and you can go online. We've done a firefighter response to the Lucid Air video that our COO Dalen Zartman recorded, and it's an awesome resource. So I'll put that link in too. I'll make sure Ed gets that out. And they called us and they're like, we think we have an issue. We think one of our cars had a thermal event. Well, that wasn't the case. So what happened the next morning when the collision center came in, this is what they found. So unfortunately, that vehicle went into a thermal event, caught on fire, and it burnt up 3 other vehicles beside it that were there to be repaired. One of those vehicles was the Lucid Sapphire, which is valued at about $250,000. So between the vehicle that started it and then the 3 other vehicles, it was looking at a $750,000 to pushing a $1 million loss. What happened was, overall, on a quick 30,000 foot view, is that this vehicle did not get what is called a secondary shutdown. So every make, model, and year of a hybrid electric vehicle has a unique and specific way to do a high voltage isolation, or at least most of them do. And the only way to know how to do that is you would have to have some type of reference to be able to do that. And you can get those from the ERGs that are available for the make, model, and years of all vehicles. And that can get into either cutting a firefighter cut loop if that vehicle has it. Some vehicles don't have that, so it may have to remove certain fuses to do that. Sometimes you may have to disconnect a low voltage battery. So it could be a combination of those things. Again, it's specific to the make, model, and year of that vehicle. So this particular vehicle, If you can see there on the screen there, we have the circle in the area of damage on that vehicle right there. Behind there was the onboard charger, which is a high voltage component. That high voltage component, the onboard charger, was damaged in the accident. And the safeties and switches and relays and overrides that are tied into that were also damaged. So it allowed energy to move through and backfeed into the battery. And like a slow head bleed over about 24 to 36 hours, it started overcharging the battery pack, which then created the thermal event that resulted in what we see in the pictures there. So had this vehicle had an assessment done and looked at and said, okay, well, there's not a lot of damage, but there is high voltage component damage in that area of the vehicle. Let's consider doing a secondary shutdown, which then would have isolated the high voltage to the battery pack and not isolated it from running throughout the system. This issue probably wouldn't have happened. I can't say 100% it wouldn't have, but it would be very unlikely. One thing to always remember is that unless there is a secondary shutdown, even though nobody's in the vehicle when it's parked, there is still energy moving through that vehicle. The battery packs have a thermal regulatory system that manages the internal temperature of the battery pack. The high voltage battery pack is what charges the low voltage system or the low voltage battery. So there's constant movement of energy throughout that vehicle, even when it appears to be shut off. So unless you do a secondary shutdown, then those issues can happen like this here. And that is not a carte blanche to say always do a secondary shutdown. These vehicles really do need an assessment done by a subject matter expert to determine what is the best course of action to manage that specific vehicle based upon the damage in that particular incident. So maybe we'll probably dig into that a little bit more coming up. But so you got to kind of look at different components when you're assessing these vehicles. Just because I don't know where everybody's at, so I'm just going to do a quick what I call lithium ion 101. This is a 30,000 foot view of just to give us an idea of kind of why we're having some issues here. Obviously, when the early Priuses came out, in 2000, mid 2000s, we weren't seeing, news reports with, massive flaming inferno of a Prius on fire on freeway. Well, that's because the battery chemistries were nickel metal hydride. There were different battery chemistry than what we have in our lithium ion chemistries. So in the lithium ion batteries and lithium ion chemistries, first and foremost, there is not any solid lithium. So there's lithium particles. That's the lithium ions that are infused into the materials and the electrolyte that's in there. So just to keep it simple, there are four components that make up these batteries, keeping it really simple. You have a negative and a positive side, just like in any battery. The negative side is the anode, the positive side is the cathode. Typically, the material, it can vary depending on the battery manufacturer, but typically the anode materials are like a graphite or some other substance. But the key to the chemistries are the cathode or the positive material, the positive side. That's the combination of those metals, those precious metals that we hear about. That's your nickel and your cobalts and your manganese and your aluminums. And there's different chemistries as they put these together, right? You can have LCO, lithium cobalt oxide. You can have NMC, nickel manganese cobalt oxide. You can have NCA, nickel cobalt aluminum. You can have LiPo, lithium polymer. You can have LFP, lithium iron phosphate. The key is the battery manufacturers have their different chemistries and makeup of how they put these together. And so they pick these materials because they have a great ability to do what's called intercalate. They're like a sponge. So they can hold on to those lithium ions that are infused into those materials. And while you're charging that cell or the full battery, all the lithium ions will store in the anode material. And then when you're using that device that battery's powering, all the lithium ions will move through and go into the cathode and then discharge the rated amperage and voltage that it's rated for. So there's two of the components. We have our anode and cathode materials. The third component is in the middle, in between the anode and cathode material, they place a electrolyte. It's a liquid paste or gel. Again, depending on the battery manufacturer and how they're designing it and what they're putting in there. Basically, it is an organic solvent. It's gasoline, for lack of a better comparison. So, and it's infused with lithium salts as well, as a brief description. So I'm basically putting this flammable, combustible organic solvent, that electrolyte, in between the anode and cathode materials. The problem is that the anode and cathode materials, they don't like each other. So in the design of the battery cell, the closer that I can get the anode and cathode materials together, the more power, energy, density, charge, and rating that I can get. But if the anode and cathode materials make contact or touch or short circuit, it generates heat. That heat then will do what to an organic solvent? It will start heating it up, boiling it, creating off gassing, and then that just continuously moves farther and farther until I get a buildup of more heat, more gas, more pressure, and then I can get a release. And I'll dig into that more in a second. So the fourth component that they put into these is a separator. So they put it's basically like a polypropylene piece of material, plastic, if you will, a thin piece that goes in between the anode and cathode materials. And think like a screen in a window. It has openings and holes so that the lithium ions can move back and forth for charging and discharging, but it doesn't allow the anode and cathode materials to come into contact with each other. And that is very basic overview, but that is lithium ion 101. And so we are dealing with an issue when we have that electrolyte and that organic solvent that is in between the anode and cathode. So when we have these cells, obviously lithium ion chemistries are the most prevalent chemistry being used currently. They power anything and everything in our existence, from our cell phones to our micromobiles, our toys, our drones, our e-bikes, our scooters, computers, EVs, up to fixed energy systems, power walls for residential homeowners, and full Connex containers powering and supplementing part of the grid. Our extrication tools, and most of us have moved to battery powered as well. So, these chemistries are awesome, but they're also very picky. So anytime we have any abuse to that cell or that battery pack, the group of cells, we can have an issue. So the types of abuse that we refer to are physical abuse, electrical abuse, thermal abuse, and environmental abuse. So let's do some definitions too, just so everybody's on the same page. So I can have a thermal event. A thermal event is where I have that chemical reaction that is caused and is happening at that cell level from one of those types of abuse that I just described. That can create off-gassing. A lot of these cells have microvents in them in the design of them. So then as the off-gassing builds up and pressure builds up, it may be a slower release, and it will start releasing that off-gassing that may become visible. I may visibly see it. I may smell it. I may pick it up with a 4-gas meter or my thermal imaging camera, and I'll jump into that here in a little bit. But that is what we call a thermal event. To have what's called thermal runaway is an exponential rise in temperature over a very, very brief period of time. So that's where I'm going to have that same reaction happen, but it's going to happen so fast that the buildup of the heat and the off-gassing and the pressure cannot be contained in the container that's holding the cell materials, and it will then explode or perforate like a grenade, and it will instantly release the off-gassing, and that will mix with the LEL, the atmosphere, and then I have combustion. So that is a thermal event, is any event where I'm having that reaction at the cell level. Thermal runaway is then where I'm producing combustion, if we just keep it on a level here. And then propagation is where I go from a cell or a group of cells and those cells then propagate to the cells next to it like dominoes. So that would be an example of a thermal abuse. Um, Again, these battery packs are regulated, whether it's on the fixed energy side systems or even on an EV, to maintain an internal temperature range in that battery pack. But so it's not, most of the time we're not going to get environmental temperatures that are going to create an event, but that doesn't mean that we can't. Take, for example, let's say you had an EV that was in an accident and somebody did do a secondary shutdown, which isolated the high voltage of the battery pack, but that also took out the ability for the vehicle to manage the battery pack's temperature. And let's say it was in the middle of summer in Arizona and it's parked on the blacktop. There is a chance that that radiant heat could create an issue in the battery pack. But the biggest example of thermal abuse is where I get a cell or a group of cells for whatever reason, electrical abuse, some thermal abuse, mechanical abuse. And as that cell starts having that reaction, it's building up the temperature. And if it also catches on fire, even a higher temperature, then that temperature is going to start heating up the cell beside it, which then will start heating up the organic solvent in the neighboring cell. That organic solvent, as it heats up, will start to degrade the separator in that cell, which then will allow the anode and cathode material to short circuit. And then again, like a domino effect, we get full propagation. Electrical abuse, that's where if the battery pack or the cell, it gets the wrong amperage or voltage, either input or outputs the wrong amperage or voltage that it's rated for. So if you have, let's say, an onboard charger, or even or something that manages it, even with an e-bike, up to a vehicle, up to a large system, if something happens with the management system that oversees what comes in and what goes out, and it allows overcharging or the wrong voltage or amperage to be exposed to that battery pack or cells, that can generate heat, which then the same thing happens. It can create an issue inside the cell. That heat will then cause the organic solvent to start to heat up, off gas, build pressure, degrade the separator. And then again, we go from that domino effect to a thermal event, thermal runaway, and propagation. Environmental abuse is submersion. So I'll probably jump on submersion here coming up, or some people have questions as well. But if water gets into the cell, water itself is corrosive and conductive. Obviously, salt water is a lot, more conductive. But it doesn't matter if it's chlorinated water, fresh water, brackish water. If water gets into the cell, it's almost guaranteed that that cell will have a thermal event. Whether it happens immediately or happens from our experience in through the lab and responding to incidents, that could happen days, weeks, or months later from submersion. So,
Hey,
yeah, go
Bobby,
ahead.
if I can interrupt that, you're talking about water. One of the first questions we had, what are the dangers of applying water to an electric vehicle fire?
Um, so applying water to the firefighter, um, no, I wouldn't go and say there would be greater dangers than an ICE vehicle fire, other than managing, the heat and the flame production that's coming from the battery pack, if indeed that EV's battery pack is having a thermal event. So a lot higher temperatures. The flame characteristics are more like a jet, flame. So you would have to, just be, cognitive of your approach and directing of the stream, but no chance of getting electrocuted or electrical flow back through that water stream to you. These are DC, power, and even if they're submerged, you can go into the water. You're not going to get, you're not going to ride the lightning. You're not going to get, electrocuted. The vehicles have what's called a floating ground, so they're not grounded to the chassis in the design that they are. Um, I will go one step further, and I know we're going beyond firefighting, but if anybody on here does diving, does recovery, And if you get called into for a local tow and recovery agency to pull an EV out of a body of water, say it goes into a pond or a river or something like that, we suggest that you do not go in with any chains or J hooks. Go in with soft connections, because you're going to be in most of the time in limited visibility. And it's not that you're going to get electrocuted by touching the vehicle or being in the water, but if you have any like chain or J hook or any metal item in your hand and you get around a high voltage component that's been damaged, it can arc flash. So arc flashing is a larger concern overall, not diminishing the chance of getting electrocuted, but that it's very, very small. The greater danger to the fire service and interacting with it would be arc flashing, especially during extrication or around the vehicles and high voltage components that are exposed. Is that good, Ed? Want me to continue on?
Yeah, if Keith Martin, if you have any follow up to that, go ahead and type another question in, and let's take this next question quick. Would
Yeah,
you answer a call from outside of the United States?
absolutely.
Okay.
Yeah,
And
and as I just was telling Ed, I just got back an hour ago from from Canada up on Prince Edward Island because our team was called to manage an incident up there as well. So yeah, we are North America 100%, and we are working on expanding outside of North America.
okay, you can go ahead and move along. And I think we
Okay.
got, and before we finished, I want to make sure I get your number for your call center.
Okay, I've got it posted on here, so
Okay.
it's cool.
All right.
Okay. Okay. So yeah, and I'm sure most of the listeners have following social media. Another example of electrical abuse, whether is we're seeing that with the micromobiles and the e-bikes. FDNY, they are having a major issue, and I know they're not the only department, but they're having a major issue with the e-bikes, and these are being stored obviously in those areas. You don't leave your e-bike outside, so you're storing them inside. And then whether it's consumers are buying extra batteries, but they're buying off-brand batteries, and maybe those batteries aren't made, even though they're rated at an amperage and voltage, but maybe they weren't produced at the right amperage and voltage, so they can't handle the charging that they're supposed to, or the onboard charging unit of the actual bike is having an issue. So those are all the things that the investigators and FDNY are looking at. But the reality is those are all electrical, or a majority of them are from electrical abuse, is what considered, and creating these events on in mass in New York City alone, and not just there, but they're having a major issue. So the key is these cells, these batteries are inherently overall safe, and they're great, but they don't like any of those abuses that we talked about. And when we get those abuses, that's where we get into these situations of our thermal runaways, of our off gassing, of our fire events, and having issues there. So overall, we teach, as an organization, no matter who you are, if you're a bystander, if you're law enforcement, tow and recovery, fire department, anybody, we teach sight, smell, sound. So for hazard recognition, a lot comes into play when you get dispatched on a run. So for the fire service, I know it's difficult sometimes to change run cards or to change dispatching, but there's no issues, I would assume, for any of us to, when we are marking that we are en route or that we're responding, or however you do in your organization, to inquire through that dispatcher, do we have any indication when we're going on this MVC that there's a hybrid electric vehicle involved? Getting early notice would then allow us to put our mind into that mindset that, hey, I'm approaching hybrid electric vehicle, so these are the things that I need to think about and assess, maybe a little bit different than a normal internal combustion engine. But overall, let's all be on the same page that when I approach any vehicle, so if we're talking about a a vehicle accident that we're responding to, we approach everything the same way. Remember, we don't approach from the front, we don't approach from the rear, we're going to approach from the side, we're going to do our circles of safety. And keys are we want to determine, is that vehicle on? Is it possibly in drive or reverse? And we're doing those same approaches, right? Nothing's going to change there, other than I need to, if I know it's a hybrid electric vehicle, or I can recognize from badging that's on the vehicle. So Society of Automotive Engineers, they request that there be badging on a vehicle that can be visual from up at least from 50 feet away, to allow anybody interacting with that vehicle to give it an indication that it's a hybrid electric vehicle. That's not always the case that happens. What if it's dark? What if it's down an embankment? We need to do some things to determine, hey, if I already don't know when I'm showing up on the scene that it's a hybrid electric vehicle, what are some things that I can do to determine that? Is there badging? Do I not see an exhaust? Do I just notice that the unique shape of the vehicle, and I recognize that it's an all electric vehicle? As I get closer to the vehicle, do I see orange wiring and orange cabling? Right? Do I, again, I think I already said, not have an exhaust? Do I have a charge port? Do I have a charge port and a gas filler? So that tells me that it's a plug-in hybrid, right? Those different things. Ultimately, if you have no other way, by calling us or running a VIN locator. So if you have a program that runs the VIN and you can get to the VIN, then the VIN will be able to tell you. The manufacturing label on the B-post pillar, or the driver's side door or driver's side B-post pillar, a lot of times will give you some information on the month and year of manufacturing, and sometimes possibly the make and model of that. So multiple ways to determine that do I have a hybrid electric vehicle. But whether you do or don't, from here on out, on any MVC, approach every vehicle and use sight, smell, sound. So as I'm approaching a vehicle, and let's just say I already know that it's an all-electric vehicle that I'm approaching that's been in an incident, if I have any of these present, that tells me that I need to be 75 feet away, unless I am in full PPE and respiratory protection. So I'm on SCBA. So if I see obvious arcing, or I see smoke but coming from an EV, more than likely, if it's the battery pack involved, that is going to be off gassing. That is not going to be smoke. It will either be white or light gray. A lot of times, depending on the state of charge in the battery pack, the chemistries, what's going on, it can be very dense off-put. But that is an IDLH environment, so it's not smoke, it is off-gassing. Obviously, if it's on fire, if there's any major deformity or physical damage, especially like if the battery pack's ripped open and I have exposed cells on the scene, and then any leaking fluids. So let's dig into leaking fluids real quick. I had already stated earlier that the battery packs have a thermal system that maintains the internal temperature of that battery pack, and that specific temperature is specific to the OEM and the engineering design of that vehicle. But most of the time, if you're going to have any leaking fluid involved with an EV, it's going to be coolant. It can be proprietary to that OEM, but it is the same coolant basically that is used in internal combustion engine vehicles. So however you would handle if you had exposure to that, copious amounts of water, but nothing of major significance. For you to actually have leaking electrolyte, you would have to have dozens, if not hundreds of cells that were leaking and ripped open to form a puddle enough for you to have the buildup of electrolyte, because there's minimal electrolyte in each one of the cells. Typically, if you have that much damage anyway, that vehicle is already going to be in a thermal event, whether it's off-gassing and or combustion's already happened, or it's on fire. So in the case that you do interact with electrolyte, copious amounts of water, try not to get it in your eyes and in your face, and if it does get on you, copious amounts of water. Next is smell. Again, I already kind of hinted earlier, there's a multitude of different chemistries, but a lot of the chemistries, when I'm having a thermal event, when I start getting that reaction in that cell, it creates a sweet electrical burning odor. It's been said that Tesla, I think, coins it as like a sweet cherry bubblegum electrical smell. I always like to say when you've walked in somewhere and you smell ballast overheating, so you got that electrical smell and think you just put a big old cherry or fruit Jolly Rancher in your mouth. So it's just a sweet electrical smell. That's that electrolyte interacting and going through that reaction that produces that smell. And then obviously, if that vehicle is making any of the sounds listed here, it's buzzing, it's popping, it's hissing, and more so if I know it's a hybrid electric vehicle, all of those tell me if I'm law enforcement, back up, call the fire department if they're on scene. Tow and recovery, do not load this vehicle on your truck. Fire department, this is the fire department's scene to manage until they can mitigate it and put it into a safe state for that chain of custody to hand off. And then as a bystander, the same thing. If you roll up and you have this, just understand that if you have any of that, there's a good chance that you're putting yourself into an IDLH environment. And this is going to come into those kitchen and tailboard table talks that we have, that we do all the time in the fire service. And you're right. What happens if you roll up on scene and somebody's unconscious in the vehicle and that vehicle is off gassing? So understand this, even if the vehicle is not on fire, but if it's off gassing, you need to treat that patient and that vehicle as if that vehicle is on fire. So that vehicle needs to be, or that patient needs to be rapidly removed from that environment. And then once they're out, you can, consider your spinal motion restriction. But that is equivalent to the vehicle being on fire. So, that's where we risk a lot. We risk a lot to save a lot, and we make those informed decisions. And that's the key, having the information to know what I'm going into and what I'm doing. So utilizing sight, smell, sound gives anybody the ability to at least initially say, this vehicle is unstable and it needs to be managed by the fire department. And if I'm the fire department, any of these tell me I need to be in proper PPE and on respiratory protection. The hazards for all these are electric. So, right, the gas is highly conductive. We already talked about the arcing potential. So, especially with high voltage components and damaged and exposed, there is arcing potential, especially if we're getting up around there with like halogens and things like that. So, just always be aware of the areas that you're pressing or you're pushing or that you're managing. And then there's stranded high voltage. So just understand that when these vehicles are in an incident, if somebody just left the charging station and it's at 80% state of charge, that vehicle, unless it's having a full thermal event as it's burning up that state of charge, that is the state of charge. Even if you do an isolation, cut a firefighter cut loop, remove fuses, whatever specific to that vehicle, that doesn't mean that the battery is now no longer charged. It just means you're isolating it. So if it was at 80% state of charge, it's still at 80% state of charge. 2 weeks later, it's still at 80% state of charge. Unless you do an engineering process that typically isn't done in the field to remove that energy, or the vehicle catches on fire and it burns up all the energy, or the vehicle submerged, water gets into the cells, catches on fire, and burns up all the energy. So that is the concept of you have high voltage and stranded voltages that can be in that battery pack. Also understand, I didn't have the slide up and too much to go into tonight on the different vehicle designs, but a lot of these vehicles, because of the regenerative braking, have inductors, conductors, or super generators that are behind 1, 2, 3, or all 4 wheels. Basically, when you're actively braking, that converts that energy into electrical energy and feeds it back into the battery pack to charge the battery pack while you're driving. The same thing happens with the electric motors. As you let off the accelerator, the motors start running in reverse, which starts slowing the vehicle down, which back feeds energy back into the battery pack to charge it while you're driving. So the capacitors in those components can be upwards of 400 volts and can maintain that. So even outside of the battery pack, we can have higher voltages throughout systems of the vehicle. The off gassing is highly toxic. So there is it's massive amounts of hydrogen, CO, and CO2. There's probably about 80 to 100 different off gases involved in the off gassing. Yes, there is HF. I'm not going to go into HF right now, but if we have some questions coming up, I will dig into the HF. Just understand that even a recent study that came out does show that a electric vehicle does have more HF than an internal combustion engine vehicle. But the internal combustion engine vehicles in that specific test that I'm referring to was still at 300 to 400 parts per million, even though the EVs were at 600 to 700. So the concept is you don't hear people saying, oh, HF is going to kill us from a internal combustion engine vehicle, and it's far above the IDLH massively. So it's the environment, and you got to look at it in comparison. Also, just throw it out there, most of the HF that's being seen in our own tests and also in the other tests that we've looked at, it's not constant. It's happening in bursts. It's happening in 2 to 3 to maybe 4 or 5 second bursts. So it's not continuous. In our testing, we see a spike in HF right before combustion. Then once we have combustion, it burns up the HF and all the other VOCs. So there's another little hint. If it's doing something bad and it's burning, it's far better to be burning than it is to not be burning and off gassing. Because I'm burning up a majority, if not all, of the bad stuff when I am in combustion and burning. And I understand the limitations there, and we'll talk about that with questions. Exposures, do I have the ability to let it burn, and the different scenarios to consider there. But as a firefighter, my big concern is I understand that I need to be in my PPE and I need to be in respiratory protection. So at that point, I'm still really concerned about the amount of CO, CO2, and hydrogen, especially the CO and hydrogen, because it's massive amounts. What we've seen is that we're looking at 1 to 5 liters of off gassing per watt hour. Or comparison could be about 2 to 10 liters per amp hour. So there's a massive amount of off gassing when this happens, and that range is because of the different chemistries. So when I'm putting off that much hydrogen and CO, I'm creating that's explosive, right, and flammable. So when I'm in more of a confined space, let's say I'm in a residential garage, now it's building up in there and potential for explosion when everything gets to the right, mixture. When I'm in a parking garage, right? Parking garages are limited ventilation sometimes, and if I'm in a sublevel of a parking garage, even more of an issue. So understanding that I may be in my protective gear, but I still need to know that the off gassing is highly explosive, and need to understand that when I'm managing these events and looking at the location of that vehicle. And then obviously highly flammable and highly combustible. Now, as a fire department, we have 2 extra tools that help us with that sight, smell, sound. So I would implore, I'll come back. I would say each and everyone on you here that when you respond to an MVC from now on, you get off your truck with a thermal imaging camera and a 4-gas meter. Because if it's a hybrid or electric vehicle, I'm going to utilize those 2 tools to help me determine as part of my sight, smell, sound. Your 4-gas meter, I'm particularly and specifically going to be looking at the CO. I can have cross sensitivity with the amount of hydrogen and also LEL hits, but the CO produced, obviously, I can pick up the CO with my 4-gas meter as one of the meters, or one of the components that it's looking for. When you have an all-electric vehicle, there's nothing that produces CO. So as I'm approaching that vehicle and doing my scene size up, I've got my tick and I've got my 4-gas meter out. And as I'm approaching that vehicle, let's say that I don't have visible off-gassing, but as I'm approaching the vehicle, I start getting hits on my CO. 7 parts per million, 10 parts per million. I'm up to 20 parts per million. That indicates to me that until proven otherwise, that vehicle and that battery pack is having an event, which means 75 feet away, unless you're in full PPE and SCBA, because there's nothing else that would be creating that CO. So the CO is a good indicator to pick up that. Now, obviously, you got to look in your environment. If you're inside of a structure and there's other gas-powered machinery, forklifts, other trucks, you would need a baseline of what your CO is, and then to determine if there's elevated CO. But on a regular incident, on the roadway, as I'm approaching that, use that 4-gas meter as part of that smell, right, to add to it. Here's an example from the lab just to show rapid combustion and toxicity. This is a residential power unit. The bottom right is a thermal imaging camera video, and you can see that I have off gassing. I'm having a thermal event, and then now I go into full thermal runaway. That video was just to show you. And again, if you look at the bottom right, look at the temperature of the tick. It's at ambient temperature, about 90-ish plus degrees. I am looking through a metal container, through cell packs to cells. My thermal imaging camera doesn't necessarily pick up temperatures at the cellular level. I'm not going to go into it today but the different chemistries have different thresholds that they have to reach for that cell to even be able to go into a thermal event. But I can tell you this, for that event there, those cells had to have been at 300 or higher degrees Fahrenheit. That thermal imaging camera obviously pick it up temperature-wise, right, until we had combustion. But I just show that video to just show you how fast that these can propagate. So the initial off-gassing is a thermal event, and then I go into a full thermal runaway. Time, just so we can see it. The other thing I want you to watch is watch the top of the unit and the bottom of the unit, and we call the gases striate. So based on the different gases, some are lighter than air, some are heavier than air, right? And then they react accordingly to their makeup. Here we go. Again, just pay attention. There we go. All right, so this next video, so as we talk about thermal imaging camera, initially, I'm not probably going to be able to get a temperature at the cell level. But I'm going to use my thermal imaging camera because in this next video, you're going to see four grids as well. The bottom right is my thermal imaging camera. We took this device and we are charging it. So it's going to go into a thermal event. Look at the bottom right. This is real-time video on all four screens. You do not visibly see off-gassing on the other three video views, but on the bottom right, it looks like a smoke machine. That battery pack, those cells are off-gassing. That is a thermal event. Your thermal imaging camera can pick that up before even your visually could if it's early on in the event. So that's where that thermal imaging camera and your four-gas meters as we're approaching these vehicles come into play. Again, that's an ideal H environment. That means 75 feet away unless you're in PPE and SCBA to interact with that vehicle. This is a cell pack that has 6 or 8 18650 cells, and they were at about 50-60% state of charge. And that was only about 4 or 5 of the cells that had that event. That's physical abuse. That was a small nail that punctured into the battery pack, and you have the immediate reaction that you saw there. If you look behind there, you can see.
Hey, Bobby, you're cutting in and out with your audio at times.
Okay. I apologize. Here. All right. Can you hear me now, Ed? All right, I'm going to continue on, hopefully. So what you saw behind that,
yes, we can hear you.
Was a unit. I don't know why I am on automatic. So, okay. So what I'm setting up here, we were testing a suppression agent in a unit. The reason why you see the wood walls around it is because again, we signed NDA, so the client didn't want their design of their cabinet to be anybody to know it. But we were testing a suppression agent. Our engineers are back over to the left in the lab, and we pre-installed 2 vents in the container because one of our first questions we asked was, "What's the deflag for your container?" Well, what's the pre-engineered weak point that it will allow it to release so that it doesn't explode like a grenade? And at that time, they said the doors were, and so that was unacceptable to us to do the test. So we told them that we would need to install a couple vents to open up to release the off gassing so that we wouldn't have an explosion. 15 seconds before this video, our engineers called out and said we have levels that are far exceeding in the explosive range. We need to open up and vent. And then this was 15 seconds after that saying open up the second vent. What you're seeing here is not combustion yet. This is full off gassing. There's a thermal vent going on, and then the explosion that happened there. So when it comes to the fixed energy side, make sure you get training. Make sure if you have these in your area and you respond there, that you don't just go up and open up any one of these containers or doors. You do monitoring, call in a hazmat team, and take your time. It is not my story to tell, but you can reference and look up the Surprise, Arizona incident that happened there that will kind of paint the picture of how dangerous these systems can be, and that you need to just be aware of how to safely approach them and manage them. And again, I would say utilize our service. I'll give that number out later, and we can help manage those in real time for you as well. So when it comes to suppression, again, I'm just putting this all together. I don't have all my slides up here, but obviously life safety is first. I got to consider exposures. I got to look at that fuel load. Think of the state of charge in the battery pack as your fuel load, right? How many cells are in the battery pack? Some of these vehicles can have 8,000 cells. The watt hours can be, depending on the make, model, year of the vehicle, could be anywhere from 50 kilowatt hour battery pack up to a 90 plus kilowatt hour battery pack. What is the state of charge? Did they just leave a charging station? Is it 50%? Is it 80%? Right. So the more charge you have, the more fuel load you have. It is a great way to equate when we look at these. Right. So how long is it going to burn? What's it going to do? There is no 100% guarantee, but based upon the chemistry, the state of charge, if that vehicle were to have an event and it catches on fire and you let it burn, if you can protect exposures, it's not on a bridge, it's not in a tunnel, and you can let it freely burn. It very well could burn itself out in an hour and a half, 2 hours, right? I'm giving you broad ranges. But then if it burns itself out, it's going to burn up all the energy, and then that vehicle can be handled like any other vehicle. If you start spraying water on it, and you're spraying water on the vehicle interior, obviously you're going to have an interior vehicle fire, just like an internal combustion engine. You could be putting that out. But if the battery pack's involved and you're spraying water on the outside of the vehicle or even the outside of the battery pack, you are not doing anything. You cannot reverse thermal runaway once it starts, and you cannot cool the battery pack externally enough to prevent thermal abuse of the cells that are in thermal runaway from causing the cells beside it to propagate. So basically, if you're on fire and you're spraying water on the outside of the vehicle and the battery pack, what could have been an hour and a half, 2 hour event, you are knocking out combustion, which means you're not stopping thermal runaway. Now I have a lot more off gassing because it's not being burned up, and I've just slowed the whole process. So now it could be a 4 hour event, and now it burns itself all the way out or it stops. And I've just flown an exorbitant amount of water. Now I've got to be concerned about the runoff. And did I really even need to do that much water, right? And I'm not saying that in certain circumstances that might not be your only choice, but the only effective way to use water, if I'm going to actually say I'm going to want to attack this and try to mitigate it to that part of the battery pack and stop the progression, is I have to get water inside of the battery pack. And I need to go about doing that by manipulating the vehicle and observing, are there any open areas of ventilation in that battery pack that were created from the thermal event or the accident, physically ripping it open, or that thermal event will burn through the battery pack, creating an opening that I can direct water into that part of the battery pack. When I get water into the battery pack, water gets around the cells, and then that water is cooling and protecting the cells that are yet in a thermal event from going into a thermal event. And at that point, I may be able to manage that vehicle. And in 30 minutes, 45 minutes, I may have everything stopped, right? Um, but here's the reality is if that vehicle and I stopped it and it didn't burn all the way up and I still have state of charge in any part of the battery pack, the likelihood of reignition is pretty high. Um, and I already mentioned water. It does have an issue that if water gets to the cell level, it may protect it from progressing to the cell beside it. But water can also create an event by creating the reaction inside the cell when it gets in there, and then make that cell go into an event, whether immediately or minutes, hours, days, months later. So, what sometimes could be an hour and a half, 2 hour event by just letting it burn may become a multi day event of reignition and putting it back out and reignition as long as there's state of charge in there. When it comes to agents or devices, I'm sure I'm going to get questions and I'll answer any of them, but let me just throw these out there now. From our testing, there is not an agent currently that is the magic elixir. Nothing works better or cools better than water. I don't care if it's an emulsification agent. I don't care if it's an encapsulating agent. I don't care if it's a surfactant. The science collectively proves when you look at large scale testing. I'm not interested in when you take 10 cells or 50 cells and seeing what works. I am only interested in when you take a full battery pack or a full system and what works the best. And currently, water is the best cooling agent collectively. Now, officially, that's going to be put out in the next year and a half because we will be testing anything and everything that an agent or somebody wants to test to have to be a part of that study to show. But it's going to be based upon large scale full EV testing to determine that. So just to clear that up, water is still the best and only effective cooling agent when it comes to full scale involvement of vehicles or on the fixed energy side. Now, I'm not limiting to this. When I'm looking at large maritime vessels with large systems and large pumps that can manage agents, that's a whole different story. But specifically, I'm talking smaller systems and EVs. Water is still the best agent. One other thing I will say is that we aren't an advocate of anything that punctures into the battery pack as an organization, and here is why. There's a lot of there's not a lot of requirements when it comes to the OEMs to have everything the same. So that all the makes, models, the different OEMs have unique designs. And even the battery manufacturers, right? Your different battery manufacturers that make the different cells and different chemistries. There are two things that every single battery cell manufacturer, CATL, Panasonic, Samsung, BYD, and every OEM, Tesla, Chevy, Ford, Audi, Porsche, BMW, they all collectively say two things. And if you look in their ERGs or their manuals, it will say if there is a fire, use only water. And second of all, they all collectively say do not ever puncture, penetrate, pierce, or pressurize the high voltage battery. So I know I'm going to get questions, but as an organization, we cannot put out something that says against what every single collectively battery cell manufacturer and OEM say. Do not ever purposefully puncture, penetrate, or pressurize that battery.
So, Bobby, let's clear something up here. Mike will send in a question. When you talked about being able to get water in on the battery earlier, Michael sent in a question that says several webinars and classes I attended said never to pierce the battery pack shell and try to cool the internals. Now this webinar says to pierce it, ? Confused. So I think when you were talking about the fire, if you could get water inside the battery, but I don't think you made reference to piercing the battery.
No, and so let me clarify for him. No, I made reference to say if you can manipulate the vehicle and you observe where it is naturally venting out because the thermal event eventually will create an opening through the battery pack as it burns and releases the off gassing, then you utilize that entry or that opening to then direct water in. Yeah, I did not, just to clarify, I did not say purposely create that opening. And then now, as I just expressed, do not ever do that per us or the OEMs.
So, all right. Yeah. And I'll just take the Curtis Taylor says recommendations on piercing nozzle use. No.
Now, Ed, we were talking earlier, there's some, there's a lot of new designs, and I believe it was over in Sweden. They're looking at using a nozzle that's not a piercing nozzle, but the flow is like a cutting nozzle that the water will infiltrate through and cut through the battery pack to get in. So, as we move forward and progress, right, everybody's looking, for what's the best approach. And I'm totally open to designs and options, because as a firefighter myself, I want that magic button. I want that magic elixir, that magic tool that's just going to be the one-stop shop that manages this. Currently, that's just not the reality, but I'm hopeful. So I'm totally into anything and everything being tested and thought about. It's just we need to keep everything in our industry saying, hey, let's not just jump on everything and say this is the answer when collectively we don't have that full answer, right?
So at this point in time, it's water, and don't pierce the battery.
Don't pierce the bottle with the battery. And then if you let it burn is our number one recommendation. If you have the ability to let it burn, protect exposures. If you are going to use.
Dennis Musser had a comment. So foam has no effect. Again, water's the solution.
Yes. And so let me just dig into your foams and your agents, whether they're an emulsifier, an encapsulator. Think of it in this way. A lot of times certain agents are actually conductive themselves, so they actually propagate the situation. But even the ones that aren't, they disrupt the fire tetrahedron. So it will knock out will knock out flame, but it does not stop thermal runaway. And remember earlier I said, if I'm not burning, then I'm producing a mass amount of off-gassing and then creating an explosive environment. So now I've got the buildup of all that off-gassing, and then that encapsulating or emulsification agent, as it dissipates out and wears off, then everything's back to the LEL. And then instead of reigniting, a lot of times I get an explosive situation and then back to reignition. So a lot of times the foams and the agents can create even worse conditions through their mechanism of action. And then ultimately the key is that water still has the greatest cooling power and potential currently, from all of our testing and supported from a lot of other testing that is on the large scale side. When you do have an incident, when is it good? When can I say, as the fire department, let me hand this off, right? So if I have an off-gassing event, and if you have an event where you're off-gassing, and I visibly see that off-gassing, remember, white, light gray, or I smell that sweet electrical smell, I'm getting CO hits on my four-gas meter, I visibly see it with my thermal imaging camera as I scan the bottom of the vehicle, any of those indications, that is the fire department, that's an unstable vehicle, right? So that vehicle cannot be handed off to tow and recovery law enforcement. You still need to be on scene. Concept would be, we would never go into a room of content structure fire, put it out, walk out while it's still smoldering, and leave until the homeowner, they're good to go back in their house. No, we salvage, we overhaul, and we manage that scene until chain of custody, we can hand it off safely to the next entity. So if I have an off-gassing event, you're not going to like this. Off-gassing means I have a high likelihood of going to combustion, but I don't necessarily always go into combustion with off-gassing. Our longest event through our call center, we managed an off-gassing event continuously from an EV for 18 and a half hours. So for 18 and a half hours, that EV was off-gassing. The battery was having a thermal event, which means that vehicle could not be moved, could not be towed. It had to be managed. Anybody interacting with it within 75 feet need to be in the full PPE SCBA. And there is no reversing that. You can't spray water on the outside of the battery pack to stop the thermal runaway or to stop the off gassing. The only indication of using water may be if you want to control the direction of the off gassing for whatever reason. It was sitting in an area where it was blowing away you didn't want it to blow, using hydraulic ventilation. And if you're spraying water on the outside of the vehicle battery pack, again, you're not doing anything to stop the thermal runaway, and you're now are mixing water with the off gassing, and then now you're getting the runoff, which can create hydrofluoric acid and multitude of other things. And then if you are ever going to spray water, another concern is you need to try to think about damming and diking if possible. We're limited and we have to manage that emergency first. But if we can think about these things as we're doing it, if at all possible, then we put that in there. So just putting that in. So if my off gassing is stopped, and if it was on fire and my fire is out, I need to scan that vehicle, and I need to scan the battery pack through the floorboard as much access as I can get, around and under the vehicle as much access as I can get. And I need to not have any hot spots greater than 200 degrees Fahrenheit. Once I have nothing above 200 degrees Fahrenheit, I start a timer for 45 minutes minimum. After 45 minutes, if I still have no hot spots greater than 200 degrees Fahrenheit, and I have CO reading at the vehicle, preferred 0 parts per million, but at least 50 parts per million and under and dropping, then and only then, best practice, do I say to tow and recovery law enforcement, you can load it. This is your vehicle now. I will go so far as to say also that if you have any of those events as the fire department, I would not leave. I would stay there as tow and recovery loads it, because unless that vehicle burnt all the way up, the likelihood of a reignition is very likely. So you would be there to help manage it. I know in a lot of our local departments, if we have any off gassing or a fire event, once it's all done and managed, and we have those parameters below 200 for 45 minutes, CO is negligible. We will follow the tow truck back to wherever they're taking it. Just in the case that there's an incident on the way, then we can help manage it and come up with a plan on the way. So that is post-incident best practice. A lot of people don't realize that for probably about the past 5 or 6 years, there's actually, or maybe a little longer, there are already federal standards in place that are specific to hybrid electric vehicles when they've been in an accident, a thermal event, a submersion event, or high voltage component damage or recall. These two standards are Society of Automotive Engineers. So SAE has a lot to do with the roadworthiness of vehicles and testing and oversight. And SAE is an international organization. So even if you're up in Canada, SAE, again, being international, that is SAE J2990. And then the other one is National Transportation Safety Board 20/01. So you can buy these online. They won't let you look at them unless you purchase them. They're 70 to 80 page documents, but I'll give you a brief overview of what they say. So the SAE J2990 and the NTSB 20/01. By the way, these standards and guidelines are also supported by all the other federal agencies, DOT, DOE, NHTSA, NFPA. So they have a lot of traction. The problem is that nobody knows that they're there and that they exist. And just to clarify, we all know in the fire service, standards are not legislative, right? There's nobody walking around with NFPA writing you a citation for not following an NFPA, regulation or a standard. The same with this. But what comes into play is that they're here and they represent best practice, just like in the fire service. When you have an issue where there's loss of property, loss of life, or injury, obviously it's going to go to litigation. And in the fire service, we're going to be held to what's considered best practice. They're going to say, well, NFPA dictates this is best practice. So how did you act? How did you interact? What did you do? What did you not do? So the same thing is going to be with these standards. So if any type of loss of property, like let's use the example when I started this presentation of the vehicle in upstate New York. That's in litigation right now because there's these standards that I'm getting ready to talk about, and it has specific uh, uh, requirements of how they're towed and how they need to be stored. So that's still being in litigation because one entity is saying to the other entity, you brought me a vehicle that you didn't let me know was an issue, and you put it in a place that it created this issue, right? Um, so standards, although they're not legislative, they do play a part as best practice. So let's go over these and understand how that plays for us in the fire service, especially. So both standards collectively say that anytime a hybrid electric vehicle has been in an accident, no matter how minor, moderate, or major, they don't specify. They say any accident, any fire event, any submersion, or again, high voltage component recall or specific damage, that vehicle has to be labeled or ID. You are required to put something on that vehicle that says this is a hybrid or electric vehicle, and it is a potential hazard or known hazard based upon it being in an incident. So fire service wise, for years, how many times do we pull up on an MVC? We make sure the patient's getting EMS care if needed. We've made sure that that vehicle is in park. We've made sure that it is turned off. Sometimes we disconnect the low voltage battery. It's not on fire. That vehicle is stable. It meets our requirements for chain of custody. And we sometimes clear the scene before tow and recovery get there. Now, process this. You have an electric vehicle that's slid off the side of the road. The front wheel is rocked up under the vehicle from hitting a curb and going into a guardrail. It's turned off. There's no arcing, hissing, popping, no off-gassing, no funny smell, and everything looks good. But I don't, because the standard says I need to put something on the vehicle that says, hey, this is a hybrid electric vehicle. It's been in an incident, potential hazard or danger. And we leave the scene. Tow and recovery gets there. They're not familiar with any of this. They load it on their truck, and as they're driving down the road, the vehicle, because it had high voltage component damage, unseen or unassessed, starts going into a thermal event, starts catching on fire, off gassing, and starts shooting cells into oncoming traffic and creates an issue. Whose responsibility was that, right? And so I'm not here to get into the debate, but when we look at best practice, there's a federal standard and guideline that says it needed to be labeled, and it can go right back to us as the fire service that we didn't at least write something on the window or wait and verbally tell the tow and recovery or put a sticker on it that we designed or that someone's designed that says, hey, this is a hybrid electric vehicle. It's been in this incident. It's a potential hazard. You need to know that for chain of custody. And let me go right back to that room and content fire, residential fire. We would never walk out. It's still smoldering and tell the homeowner they can go in it. So why would we take that chance with an electric vehicle and not make that communication with the next entity that's going to take control of that vehicle? The standards also say that that vehicle needs to have a risk assessment done to determine the known or potential hazard that that vehicle has based upon the damage to the vehicle. So just like that scenario in the beginning, right? The damage was minor. It didn't look bad. But if an assessment was done by a subject matter expert, they would have determined based upon the damage and what was behind there that the high voltage onboard charger was there. And that would then necessitate more than likely that it would have gotten a secondary shutdown, which then would have helped manage that vehicle and probably not allowed it to have the event that it did. So that's where the risk assessment comes in. I know you're all shaking your head because the intent, more than likely, this was, governmental agencies writing this, was you could call the OEM, right? I'm sure that was their intent without speaking for them. So if I had a Tesla have an event, call Tesla, right? If I have a Mach-E Ford, call Ford, right? And we all understand that Monday through Friday from 8 to 4, you would be lucky to get anybody on the phone, much less Saturday night at 2 o'clock in the morning, right? So I'm going to come back to that. But it also says that you individually become a subject matter expert per the standards. If you have an intimate knowledge of the chemistries of lithium-ion batteries or the batteries that are involved in that incident, You have intimate knowledge of that make, model, and year of the vehicle. And a lot of times you can utilize ERGs to give you that information. So, there are ways to go around, because the intent of the OEM is not going to come to fruition. Then, based upon that assessment, there are towing requirements based upon how they need to be towed. Most of the time, that's per the OEM's recommendation. They're never to have wheels spinning. They're preferred, most of them, to be on a flatbed or rollback. And then a lot of them will allow, recommended wise, that they can go on dollies. The weights of these vehicles are exponentially higher than their counterpart internal combustion engine vehicle. So even on the tow side, they're having challenges because they have to upgrade to beefier dollies to be able to handle the weights of the vehicles. So, the amount of issues that these are creating in different industries is it's hard to quantify, because it's just constantly every day learning something new. And then there's storage requirements. So let me use what we use. We use a green, yellow, red assessment coloring and labeling system. So if you do an assessment on a vehicle, and we do an assessment on a vehicle through our call center, and it comes back that the damage parts of the vehicle, the battery had no damage that is physically known or seen, the vehicle isn't exhibiting any signs of the sight, smell, sound, and where the damage was at, there were no high voltage components in that area, more than likely that's going to be a green. That means it can be towed per the OEM's recommendation, and it can be stored in general population. If it's a yellow would be, as a broad example, maybe something that had a high voltage component damage, like, let's say, the vehicle in the beginning of the presentation that needed a secondary shutdown. That would be a yellow. That needs to be put in isolation for a minimum of 48 hours, and then a second assessment done. And then if you have a fire event, an off-gassing event, or the battery pack has massive damage, that would be a red. A red is required to be in isolation for 14 days minimum. They define isolation as a 50-foot radius with nothing around that vehicle or above it. A lot of tow yards and salvage yards don't have that much room. So an alternative is they can build what's called an isolation bay or barrier. That can be brick and mortar, concrete, earthen. A lot of our partners are using the bin blocks, the 2 foot by 2 foot, but like 4 or 6 foot concrete blocks, and building them. The specs are on a wide spec. They have to be as tall as the vehicle, wide enough to open up both doors for ventilation of the vehicle, and deep enough to fit the vehicle in. So the concept is there. If that vehicle has a thermal event and catches on fire, and it's in isolation, that vehicle will not propagate to an exposure, and it can be isolated to just that vehicle. And more than likely, best practice would be to let it burn and burn up all of its energy. So that is the federal standards that are out there. And that's where we come into play. About 3.5 years ago, 4 years ago, when we started the ESA, one of the first things we did was we addressed that concept of the call center. And we said, we need to provide a real-time call center, because it's not going to work to call the OEMs. And so our call center is staffed by a full-time firefighter, rescue technician that works at our burn lab, that does active response with us as well. So they are intimately knowledgeable of these systems, these batteries, and they have the ability, when they work with you in real time, from tow and recovery to fire, law enforcement, environmental cleanup agencies, you name it, we can help manage that incident and give real-time guidance and advice. On the tow and recovery side, we go so far as to do the assessment, and then as long as they follow the recommendations of towing and storage, that takes the liability off of them and puts it back on us to help keep them safe and compliant with the standards, and to mitigate any loss of property or life or injury. So that QR code there is, we have an official app, but that's more currently for the tow and recovery. This is what you can do. Open this up here and save it to your home screen. It will be our ESA emblem. And then by hitting that emblem, it'll immediately open up and you can hit call an agent. So you don't have to memorize 855 ESA safe. But that is our call center number, 1-855 ESA safe.
So Bobby, just the numbers, 855-372 7233.
Yep. Say that again.
855-372-7233. Okay. And the reason I ask is when we did your podcast, I put your phone number in both of my phones
Oh, okay.
and have you stored in my phone already. So I guess what I'm saying to you folks, if you're somebody that might be in charge of one of these incidents, put the phone number in your phone. Don't try to remember it at 2 o'clock in the morning when you just got out of bed. Put it in your phone. I have it stored in my phone under ESA. Easy enough to remember. I don't have to remember an acronym. I got the phone numbers in my phone. But I don't chase fire anymore. But I put it in there just in case someone calls and says, hey, what do I do now? I can tell them to call you.
Yep.
We do have a lot of questions, and I'm going to go to the chat first and work our way down through those, and then we'll go to the Q&A. So, folks, I know we've been gone for a while now, but this has been well worth it. So I'm going to just make sure that I don't miss anything here. I know we had a big question. All right, here's one. Once the battery pack is pierced, and then the water will run run down across the ground, possibly seep into the water table. It's one thing if the battery compartment is damaged in an accident, but it's different if it's damaged on purpose. And that's more of a statement than it is a question. I got to back up here. I know we had, I'll find it. Here we go. Bobby, our company, K3 Fire, provides ultra high pressure fire suppression. And we've had several departments using our system combined with F500 foam and their solution for suppressing lithium ion battery runaways. A couple of these departments are also using our Turbo Pierce product to penetrate the battery. This product uses water, aggregate, and an encapsulating foam. We have not endorsed the practice, but F500 seems to be confident. I haven't received any negative reports. Do you believe this would work? And would your company ever want to try out the system? We'd love to have a controlled test.
Absolutely. So I don't know how we'll do it, Ed. Share my follow-up, my email, but I'm going to make sure my email gets out to everybody from any questions that didn't get asked or answered today through the remainder of this. You 100% can get a hold of me, and I will get you any information that I can get you, and have open dialogue. And yes, sir, we are open to anything and everything. So, but yeah, I would love to have some dialogue with you, particularly, outside of here, and see what you're looking for, and then
all right.
Would love to do that. Yeah.
All right. So
Ed, I'm sorry not to interrupt you, Bobby. If you could go back to that one slide with the QR code just to have up, I think some people still wanted to scan it.
Yeah.
While we go through these questions, that I appreciate it. Thank you.
Okay. Time out.
We'll make sure your email address is in the email that goes out to everybody tomorrow. So, Doug Eno, you'll be able to get Bobby's email address in the email you receive tomorrow. Let's see. Other than a visual inspection, what is a preferred way to test the charger or battery packs in the field to see if thermal runaway may occur?
So reread that. I'm not sure
Other than a visual inspection, what is the preferred way to test the charger or battery packs in the field to see if a thermal runaway may occur?
Okay. So visually looking at the vehicle, or if it, in the battery pack itself, do I see any openings, cracks, ripped open? Just to give you a story, we've had 3 or 4 calls just the past year of tow and recovery that they went on a flat tire, right? So that's not even an emergency. But the first question you're going to ask is, what caused the flat tire, right? On three events, they ran over something that, as they ran over it went up into the battery pack, which then caused the event. So observing visually, yes, sir, that would be the first. Other than that, there's going to be no indication other than that sight, smell, sound. There is nothing in the field currently that would be something first responders could use to test the state of charge, other than if the vehicle is on to see what it's charged at. There are things like called cell balance tests. So yeah, getting deeper, there's engineering processes. One of our lead engineers, Dirk Fuchs, who we also teach, we offer IMI certification, which is a European certification because there's no certification yet currently in the US on battery pack dismantling and state of health and diagnostic testing. So
Well,
in our burn lab in our classroom, we also teach those classes. And there are processes to go in and actually do the state of health on a battery pack to determine at the cellular level, do I have damaged cells? Do I have a potential issue? Do I have water that's gotten into the battery pack by doing a cell balance? So there are ways and there are methods, but nothing that is a fast or easy or something for first responders to use. So we're going to be limited to observing the vehicle, using the sight, smell, sound, and on that thermal imaging, like I said, remember I told you when you're looking through a battery pack, you've got a battery pack, the outer casement. A lot of these battery packs, there's different ways of engineering them. One way it's called a modular system. So I might have let's go back the reverse. I might have a cell. Let's say that I build my battery pack with 18650 cells. So those are cylindrical cells. Think like a AA or a D battery. An 18650 is about 2.5 times the height of a AA and about 2.5 times the width. And let's say I'm going to use those cells and I'm building this make model near the vehicle. I may put so many of those cells in what I call a cell pack, think like a VHS tape, like a metal or a high dense plastic casement. And then I'm going to put those cell packs into a module. And a module is going to be like another metal box that might hold X amount of cell packs. And then my vehicle might have 20 modules placed in the battery pack, which is the over-encompassing battery pack. And then there's a cooling plate. There may be a thermal barrier. So to get to the cell level from externally looking with your TIC, you may not get those temperatures. So that's why we utilize that. If you're looking externally through the vehicle and you have temperatures greater than 200 degrees Fahrenheit, till proven otherwise, that battery pack is unstable and has the potential to have an event. So hopefully in a broad spectrum, I kind of gave some indication of assessing a vehicle.
Okay. So the next question in the chat was, is wearing lineman's rubber gloves be helpful when working with these vehicles during shutdown procedures?
Typically, if you wear your fire gear and your rescue gloves, understanding that you're going to visually avoid high voltage components, right? Don't interact with any high voltage components. And when you're doing those shutdowns that are recommended per the OEM for that make, model, and year. And again, that is a combination of one of three things typically. That is disconnecting the low voltage battery. That is, and or if the vehicle has a firefighter cut loop, disengaging that, whether it's a quick disconnect or you're cutting it. Those are low voltage, so that's like 12 volt. So you can cut those and it's going to be no different than cutting your low voltage battery. So no chance of arc flashing or electrocution, and then pulling fuses. So wearing your typical gear, interacting with those specific areas of the vehicle, you're going to be fine. And then the recommendation is, don't interact with high voltage components, avoid them if at all possible. And typically, up and around the patient compartment for extrication, you typically shouldn't have anything in that area. And if you do, because we all know that's that one accident where everything is just really crazy. Just be vigilant and trying to avoid and staying away from high voltage components.
Okay. So the next question here is, and it's actually a two-part question. What do you suggest when arriving at an MVA involving an EV with no sign of fire?
Understanding I'm going to come off my truck. I'm going to approach that vehicle as I do every other vehicle. My circles of safety. I'm not approaching from the front or the rear. I'm visually scanning the scene. I'm looking, now I'm adding in that sight, smell, sound. So I visibly don't see anything, but do I smell something? Do I have any indications as I approach the vehicle with my floor gas meter, specifically CO? As I'm scanning the vehicle, do I see any presence of off-gassing that the thermal imaging camera is picking up? As I approach that vehicle, we teach to aggressively wheel chalk that vehicle. So I typically, when I come off my engine rescue, I am pulling the wheel chocks that go to my engine rescue, and that's what I'm using to put in front and behind one of the wheels or the tires. Um, the reason why we state aggressive wheel chocks is that these vehicles have so much torque and power that if somebody were in the vehicle and incapacitated and it happened to step on the accelerator, that vehicle, right, obviously if it's in drive, it could sometimes maybe even go over like a 4x4 or something like that. Remember, a lot of these vehicles, especially ones that are already manufactured, don't make a sound. Some OEMs put a sound when the vehicle is energized. I believe as of August of 2022 or 2023, I apologize for not remembering the year. It was made mandatory that the vehicles manufactured at that date had to have some type of ambient sound or noise produced when the vehicle was turned on, and up to 18 miles an hour of movement to give indication that it was energized, right? Remember, in an all-electric vehicle too, that vehicle, a typical drive mode is when you put it in drive, if your foot's not on the accelerator, that vehicle will not move unless some vehicles have what's called a creep mode. Well, then it could. So somebody could be in the vehicle, be partially unconscious or whatever, medical emergency, and it's in drive, but their foot's not on the accelerator, and then you approach it, you startle them, or they come to and they step on the accelerator, it could take off. So that's why we advocate aggressively wheel chalking. Never approach from the front or rear, and then utilizing your four-gas meter, your thermal imaging camera, and the sight, smell, sound to give you any indication that this is having an event, and then I need to then be in proper PPE and SCBA.
Okay. And the second part of Steve's question is with fire, with people in the vehicle.
So if that vehicle is on fire and people are in it, I need to, just like any vehicle, I need to remove them and knock that fire out as fast as possible, correct? And whatever method and movement that you do. You're like, what comes first? Do I need to pull a hose to spray water? You might not have access to get to them unless you can knock the combustion out or flame. So when that vehicle is on fire, it is like when it comes to patient removal, think of it, it's just the same as an internal combustion engine for the removal part. I need to get that victim out of there. The bigger key is, what I want you to understand is that if it's not on fire, but I'm having a thermal event, I'm having off gassing, that is still an IDLH environment. That needs to be handled the same as the vehicle's on fire, which means that patient or patients need to be removed immediately. So that's ripping open the door, knocking out the window, and pulling them out of the vehicle. So let me jump in here just because in an all-electric vehicle, make, model, and years are different, but a lot of them, as a collective whole, a lot of makes, models, and OEMs, if the vehicle is in an accident and there's enough damage, or a lot of times it's tied to the SRS system, if there's airbag deployment, that vehicle will automatically put itself into a secondary shutdown if everything worked, right? And if those components weren't damaged. What that means is that vehicle will automatically shut off and isolate the high voltage to the battery pack, which means, I stated earlier, the high voltage system is what maintains and charges the low voltage. So if that happens, you lose low voltage, which means low voltage is what controls your external door handles, among other things. So if you have an all-electric vehicle, a lot of them, the external door handles are electric only. So if I lose high voltage and I lose low voltage, you cannot open the vehicle's doors from the outside of the vehicle. A lot of the vehicles, the interior doors have electric releases as well, but the Society of Automotive Engineers requires that any all-electric vehicle, that it has to have a manual release of the door latch on the inside of the front driver and front passenger doors. It's not required in the back, but it has to be in the front. So as a rescuer, if I pull up on scene and that vehicle is off gassing and I have a patient unconscious inside and the system is shut down, I will not be able to, on that particular make, model, and year, possibly open the door because the electric to the door handles have been disengaged. Then your quickest route would be to take the window and then reach inside and try to locate the manual release to open the door to remove the patient. Or if you don't have time to do that, just pull the patient out the window.
Okay. So the next one is more of a statement. It says GM vehicles have fusible links in their rear seats that will allow water into the battery pack after they burn off. I'm
Right.
assuming Paul went to a GM vehicle class, and that's why he knows that.
Yeah, and when it comes to the multitude of OEMs and designs, they're the OEMs themselves are looking at maybe not profoundly as we would want them to do, but looking at potential measures to help mitigate issues when there's an incident as well, right?
Okay.
So there's been talk for years. I mean, let's just be simple. In the fire service, wouldn't it be great if there was a port that was a water hose attachment, and if you had a thermal event, we could just hook in and flood the battery pack, right? I mean, on the tow and recovery, they would, or wouldn't it be nice for us if there was one button that was on the dash on every vehicle that was the same location that we could just push that would put the vehicle in an isolated state? But as firefighters, we know you come outside of electric vehicles. Half the time we show up and we can't even find where the 12-volt low voltage battery is, right? And then we locate it and we're like, there's a second one. Where's it at, right? And let me tag on to that to just say, on an all electric vehicle, because there's no alternator and because the high voltage battery and system charges the low voltage, it constantly is charging and discharging and moving. So a lot of the OEMs are moving toward replacing lead acid batteries for their low voltage with lithium ion. A lot of them are going to lithium ion prismatic cell type. So now when you go to do, even if you have this make mount on your vehicle and the ERG says, okay, to isolate it, you need to disconnect the low voltage battery and cut the firefighter cut loop. But you may not be looking for a lead acid battery. There is no red cable and there is no black cable. You're looking for a little Power Wheels Barbie prismatic lithium ion battery like this big that has a little quick disconnect, right? So again, resources are vital to interact with these things because there is no, consistency across, even in an OEM from a make, model, and year, things change. So,
all right. So the next question is, what's your opinion of fire blankets with water?
Okay, so understand that I believe fire blankets are a tool. They are not the end all be all. They're not the answer, but they are a band-aid and they are effective in certain situations that we may utilize in the fire service. So let's say I have a vehicle. I'm just giving, this is not all inclusive. I have a vehicle charging in a residential garage. I get on scene. Understand that anytime I have a residential house fire and it has an EV in the garage and it's the house is on fire, or I have an EV that's having an event in the garage of a residence, I have to either initially or eventually remove that vehicle. That has to be part of my plan and my incident action plan is to remove the vehicle from the structure. And then so there's talks about how do you do that, whether your vehicle has a winch, right? So a lot of times though, in my area, we kind of have a pre-set response. So we kind of always know, the first arriving engine passes and sees three sides of the structure. You leave the front for the ladder, right? So there are times where we might not have access for something to pull that vehicle out. So then it comes in, start having these discussions now. Like departments that have SUVs or trucks, their battalions, get some tow straps, things like that. Then maybe it could pull up on the sidewalk and it could pull it out and get it out. Start coming up with these plans. I mean, we talk about these in class, but too much to go into here because we'll go in the weeds. But come up with a plan to manage these. But for something like that, maybe you don't have access to pull it out immediately, and I have a house fire, I have search, I have victims, right? Maybe you throw the fire blanket over the vehicle. It's not going to stop thermal runaway, but it will cool the environment down because I'm going to disrupt the fire tetrahedron. I'm going to knock out combustion, and it will then stop the impingement of that flame and the heat on the structure. So I'm isolating it for the time being to allow me to come up with a process of what I'm going to do next. Or a vehicle's charging in a parking lot beside three other vehicles. It may allow me throw the fire blanket over that vehicle to allow us time to remove the other vehicles or the exposures. Another good one would be in a parking garage. I have a vehicle in a parking garage in an EV, and I'm having an event. Access is limited for the fire service, obviously, water supply access. Now, even removal. How am I going to remove that vehicle when it's on the second, third, or fourth floor and it's having an active event? Or even worse, it's in a sub level. There, a fire blanket may come into play to totally entomb and put around it and just let the fire blanket stay on it and monitor it for 24 plus hours and let it just totally burn itself out. But there is no set time on how long that can happen. And the one thing I want everyone to understand is that when I put a blanket over, that I am knocking out initially combustion, but I am not stopping thermal runaway. So now that I'm not burning up all the off gassing, I'm collecting mass amounts under that blanket. So I am creating a massive explosive environment. And if anyone approaches that, goes to pull that blanket back, you could have a massive issue because I immediately introduce oxygen to the right amount back into the situation. We also have seen with the blankets, though, even themselves, they do what we call burping. And 5-6 minutes in, everything can get to the right level, and you have short circuiting and other sources of ignition going on under there, and you have that explosive gas accumulation, and it shoots out, and the blanket burps up, and it shoots a fireball. So, it has its limitations, but it is not a full answer, but it may come into play to be the only thing you can use in a parking garage, right? So, and again, we have multiple thoughts with parking garages in thinking of moving up, but a blanket comes very handy.
Well, I'll certainly give you credit for something. You don't cut short your answers, which is great. That's what we're here for tonight. And we're not going to stop. I mean, if people need to drop off, they need to drop off. But we've got some good questions, and this is some very timely information. So I have a question from Tyler Sherrill. Have a question about the electric vehicle fire extinguisher. Is that something we need to possibly buy?
So, and again, let me just talk, because I don't want to talk, and discourage and talk. I'm not going to specifically talk about products, for or against. But I would say, initially, if I were to choose a fire extinguisher, the only reason that would be for like, say I'm at a body shop or a collision center, because or initial management. Probably an ABC, maybe more preferably a CO2. If I would have anything, I would prefer a CO extinguisher, CO2 extinguisher, and then maybe an ABC extinguisher. And then again, if you're going to do anything and you have the access to water, if you're going to fight the fire. But again, I'm going to go back. If there is no exposures and you can let it burn, don't put anything on it. Let it burn and let it do its thing. Right. But again, that goes back to currently, it's still until an agent, a foam, an elixir, a suppressant agent can meet the standards of a full-scale testing and show that it has better benefits than water. And when that happens, I'll be the first one on here saying product XYZ is amazing, right? And I have hope. I have hope that it's out there.
When people like you and the folks from UL finally come out and say, here it is, we'll know we finally have it. Until then, buyer beware.
Right. That's what I would say. Yeah.
What I can say that. What is your thought on the plugs they say that disable the vehicle when involved in an accident?
Okay, I'll address that one. I'll address the concept of it. How's that?
Okay.
So, as an organization, I will go so far as to say, one, until whoever manufactures a plug, whether it's A, B, C, or D, if there are multiple manufacturers or not, until that plug is tested on every single make, model, and year, I'm not going to put my life or my crew's life in full trust of that, right? Because you have to show me in a product that it is 100% going to work if you're going to say trust in it, right? So that's my first concern about any tool like that. My next concern is this, that the plug, and I'm giving a brief overview, right? And I'm sure someone here may correct me if I'm wrong, and I've been wrong. I'm not always right. But the plug, it interacts with the charge port, because most of the vehicles, when you plug in to charge, it has a safety mechanism and an override to not allow the vehicle to go into drive or to default it into drive, or to default it into park. I apologize. So the concept of the plug is, even though there's no energy being brought into the vehicle from the plug, it engages that charge port, which makes the vehicle think that it's charging, which then goes through those safety mechanisms to make sure the vehicle stays in park or can't come out of park, right? But again, first of all, until it's tested on every make, model, and year, I'm still going to always teach approach the vehicle, 360, approach from the side, aggressive wheel chalk, get access to the vehicle, access to the patient, make sure that it's in park, make sure that it's de-energized and shut off. I don't need a tool to make me do what I've been doing for years that's effective, as long as I do that every time, and it's safe and it protects me. The other issue is this, that if I have any high voltage component damage in that vehicle, what have I just done when I put that dummy plug in? It thinks it's what? Charging. So it opens up what? The pathways to charge into the battery pack. So now I have just opened up a direct pathway to the battery pack. And if I have high voltage component damage and there's damage to the switches and relays that protect that, I can actually have a backfeed, right? And a dead short that can backfeed back into the battery pack that I possibly could have opened up by engaging that plug. So what we advocate to any organization that wants to buy the plug is, we're not saying don't buy it. What we would say is, one, before you use the plug, aggressively wheel chalk and then have that plug be your backup. And we recommend only using that like an emergent or medical emergencies. And if you actually have a damage to the vehicle from an accident, then don't utilize the plug, because you could be opening up potential pathways that could create an issue with the vehicle. So that's my stance on the plug.
Well, that's certainly a great answer. So here's one. What about gases contaminating our gear from off-gassing or during fire? And what do we do to clean our gear?
Okay. So currently, so when you go back to our D&V GL test, we had tests back about 2016 when that was published. I think it was 2016. So we did some testing there too on turnout gear, and again, we've come a long way since then. Then there was some recent studies, Rise and another organization out of Sweden, I believe, and then they referenced another couple studies that was looking at like HF, and that HF for the most part was shown not to permeate through our outer and our inner shells. So what we've known now from current research and studies, and there's more to come, is that us interacting with the vehicles and fighting the fire and interacting with the scene, when we're wearing our proper gear, we're protected. The same as we are in a modern residential house fire or a modern internal combustion engine vehicle. Now the big questions are cleaning, right? Does our normal extractor get rid of any of the residual gases that may have seeped into the turnout gear? And do we need to do extra cleaning, or is there even any cleaning method? Like, is there the liquid CO2 cleaning, or other methods or agents, right? So again, I would say until, I believe a couple studies are going now currently. I think Rise is still working on one. I believe Teeks is working on a study related to turnout gear and the off-gassing. And I think FSRI as well. And I don't want to misquote, but I believe collectively there are a handful of organizations that are separate that are looking at these very things. And what we need to do in the fire service is, currently, I would say, make sure that just like after any incident, if I go on food on the stove, I'm supposed to go back and clean my turnout gear. If you're interacting with any of these, go back and do the same thing. Do the washing procedures, but we very well may learn that we need to do something more. But until those come out, I can only say that currently, to make sure you follow best practice in cleaning your turnout gear. And just to even add to that, Ed, a couple of the studies aren't just looking at the permeation's kind of been, disregarded as that's not happening, but are we holding on to it, and can it be cleaned out? The bigger one though is the heavy metals. So I know one or two of these studies are also looking at the deposit of the heavy metals that our gear is exposed to when we're interacting with these, specifically like the cobalt, and determining what is the indication of that on our turnout gear, and can it be removed during the cleaning processes as well. So right. I wish I had a definitive answer, but I'm in the same boat everyone else here is, as in we're waiting for that research and that data to come back to give us clear indication of how to manage our gear. And until then, follow your current best practice of any exposure.
Yeah, and to your point on the heavy metals, that I recorded a podcast today with Alex Meyer from the National Institute of Occupational Safety and Health. They're involved in a study now to measure the heavy metals and how much is being contaminated in the gear and how you can clean it, so on and so forth. So there's, the research and scientific community is doing a lot to help us with this. It's just sometimes it takes time to get all those results. Next question, Dave Woodleaf. I'm a public safety dive instructor. Is there any higher risk with contaminants when recovering an EV versus a gas engine while in the water?
So, obviously, there's massive amounts of dilution, depending on the amount of the body of water that it's in. But, after that event's happened and it's dissipated out, there still is potential, but probably more than likely you would be safe to enter that water and not have any issues. I would say before you enter the water, though, EPA needs to come in and test the water. So let me back up and just say something else interesting, best practice. So I have an EV that goes into the water, right? It's submerged. How do I know that I can go into the water? Well, if the EV, and everybody's probably seen videos of the EV burning underwater, right? So I can tell you that lithium ion batteries do burn underwater. They produce flame underwater. They have combustion underwater. The chemical reaction and the chemistries produce their own oxygen, so it already has a head start on that end. But remember what I keep going back to the off-gassing, massive amounts of CO, CO2, and hydrogen. So if you have a vehicle completely submerged, and if you're having a thermal event, guess what the water is going to be doing on the surface? It's going to be bubbling like a cauldron, right? So if you see that means 100% do not go into the water, because there is no indication. That means you're having an off-gassing event, but you could also have combustion. But if it's submerged, you can't visibly see. So how in the world are you going to dive and go into water, and you may dive right in and swim right up into an active flame that will, potentially injure you or kill you, right? So best practice, this sounds crazy, is if you have an off-gassing or thermal event, so if I have the obvious cauldron and bubbling of the water, even when it stops, do not enter the water for 14 days.
Wow.
And the reason is this. What if water, obviously, if I'm having an event, water got into the cells, right? It got to the cell level, creating that event. But there's no guarantee that it got into every cell. What if it's, as I described earlier, a lot of battery packs are modular. So what happens if water got into two modules, created a thermal event, and now that's happening? After 30, 40 minutes, it stops. All those cells burnt themselves up. But now you go into the water an hour later, and water activates the next set of cells in the next module. It just was progressing slowly as it was moving through, right? So best practice is after 14 days, it's not 100% guaranteed, but after 14 days, the likelihood that water will have made its way into all the cells, creating them to go into a thermal event, burning up and all the state of charge is highly likely. So.
Well, that's certainly some valuable information.
Yeah.
So go ahead. I'm sorry.
No, go ahead.
So the next question, look, I'd have never thought I had to sit around for 14 days or something like that, but that's why we're doing this webinar tonight.
Right.
So,
and again, that's best practice. That's saying, just when you go and you're interacting with one of these, you make your decisions on what you do, and the AHJ has authority. But I'm just providing information for you to then put into your mind to be like, okay, well, here is the potential issues. So, I'm not saying do or don't. I'm just saying best practice.
Gotcha. So, Joseph Lenahan, is cooling the battery housing under the car one of the best ways to slow up thermal runaway from happening?
From all of our testing and research and interaction over the past 8 years, and other sources, any external water or cooling on the external part of the battery pack does nothing on the inside of the battery.
Okay.
It does not slow it down. It's going to do what it does because it can't get the cooling effect from the outside of the battery pack to slow down the thermal abuse as it propagates through the cells. So
okay. So I think this will be the last one in the chat, but then we have 49 questions in the Q&A. So years ago, the Israelis had a quick battery exchange and could eject the batteries. Wouldn't something like that be of a benefit to separate the battery from the vehicle?
So I'm not going to specify the OEM, but there is, and there may be more than one, but I know of one OEM that has designed their battery pack that it would disengage from the vehicle up to a certain amount of forces that interacted on that vehicle. So, but whether that's good or bad, it gets the battery pack away from the vehicle and the occupants, but you still are going to have the issue of that battery pack, right? So, I'm not sure that is better or not, but
okay. You still have the incident to deal with, whether the battery is connected to the car or laying off by itself.
Right, but of course, and then I get the concept that does remove it away from the occupants of the vehicle. So then, if an event's happening while they're still in the vehicle, at least they're not exposed to that. So
okay, So Sam's sending me a note. So I'm going to go down through Sam's concern. We may run up against time with Zoom at 9:30. So I'm going to we're going to start here at the top of the list with the Q&A.
Rapid fire.
All right. We already answered that one. If an EV is put in a large container with water, how hazardous is the water? Everybody's seen what they're doing with the dumpsters all over the country now.
Yeah. So, in a handful of European countries, that's what they do. Not all the European countries, but a handful of them. Your issue, and I'm not saying that this might not come and make its way to being, more of a use here, but the issues we're going to have is that's liquid hazardous waste. So now you got to look at your individual states' rules when it comes to managing, environmental cleanups and managing hazardous waste, solid versus liquid. I know certain states you can't transport liquid hazardous waste, so I'm going to put an EV in a container and submerge it. What am I going to do with that water? But it can be managed and just looking at your state or your local regulations. Obviously, when you put that vehicle in and submerge it, that's the whole key, is that water will work its way into the battery pack. These battery packs are not waterproof, they're water resistant. So the longer that it's submerged, the more likely water will get in there. If water gets into the cell, it will 100% create a thermal event and it will burn up all that. So what you're going to have is in the water, though, that's going to be liquid hazardous waste. So that's going to have to be managed. And because it's going to burn up underwater, it's going to burn at a lower temperature than when it's just out free burning. So you also will have to deal with deposits of heavy metals that typically on a free burning on outside, it'll burn up everything. But in the water, so it can be managed. It's just looking at, the cost effectiveness and is that going to come into the full way we do it? I would venture to say that you may start seeing them pop up, like say at salvage and recycling yards, maybe in certain specific areas. I don't know that we'll get to the point where we have, dumpsters that are in fire districts and run areas that are brought to the scene. Um, but do know that that is a controlled way for the most part, depending on if you know what you're doing and if you do a salt mixture and what you're doing of de-energizing a battery, right? And I don't want to get into the science, but when you get down to the cell level, though, there's some theories on managing the water and making it circulate because the off-gassing can create coverings and coatings over the cathode material, which then will allow that cell then to go into an event because it stops the short circuit because the off-gassing creates the bubbles, right? So there's a whole scientific research and data points that are even looking at how that's managed and look at. So a lot of times on the submersion, they may keep them in there for 30 days just to almost guarantee that it is propagated through the whole system.
Okay. So this kind of goes hand in hand with, will the water used to extinguish be contaminated during extinguishment? Does this water need to be captured before it ends up in the local water system, i.e. rivers?
So again, I go back to our first, look at our, we're life safety, right? Incident management, mitigation. Part of that is if we can, during that event, if we are flowing water and we have the manpower and the ability to dam, to dike, and to try to control where the runoff goes, then we're doing best, right? But that has to come secondary to preserving life and life safety and property and managing the event. But yes, that runoff is going to be, create an event, create a hazardous runoff. Obviously, you're going to have to test the soils. Their EPA would come in and look and then determine, they've got a range of what's acceptable. And then if they find something is not acceptable, then you're looking at, major issues. A lot of times fire departments, it's not like we do what we do and we do the best we can. But I can give you an example of, let's say a tow agency has a vehicle and they put it in their yard and it catches on fire. And let's say they even have an isolation barrier and they built one and they follow the standard. And at 2 o'clock in the morning, that EV goes to a thermal event and bystanders see a fire. So they call 911. The fire department gets there and they just, instead of letting it burn and it's in an isolation barrier to do that, they start spraying water and they spray 20,000 gallons of water, which because they're just spraying it. And then the EPA gets notice and comes in and tests that soil and determines it's hazardous soil. They're going to make them clear the yard and scrape up 2 or 3 inches of soil. And I'm only speaking because this incident's happened a few times already. And the EPA doesn't pay for it. So you as a fire department could very well put a tow company out of business by doing something like that because,
So ultimately, to go back to something you said earlier, if there's no life hazard, there's no hazard to an exposure, let it burn.
Let it burn. Yep.
Then there is no runoff. There's no runoff.
Yep.
There's nothing left but a frame rail to deal with.
Right. Exactly. And let's just say everything that we're talking about here, everything's dynamic, right? So there is no absolutes because in 6 months, some study or research could come out and say actually letting it burn may create X, Y, Z. But currently, from all of our testing and data that we've pulled from multiple sources and our own data, that is the cleanest way to manage these because it's burning up almost all the bad stuff.
Okay. So this is more of a statement. The individual wants to know, I'm an officer with the Chester County Hazmat team in Pennsylvania. We currently have a program we'll present to responders regarding lithium-ion batteries. Can you recommend resources for information? We're currently using FSRI and then the NFPA recommendations, and then anything they can find at your website would be helpful.
Yeah. Go to energysecurityagency.com, email me, and we can discuss. I can send out some literature. In fact, I may do that. I typically, after we teach a class, we do a follow-up from a class, and I've got like a quick reference sheet for firefighting, a quick reference sheet for towing and recovery. So a quick reference sheet for flooded vehicles. So yeah, again, anybody reach out to me with specific requests as well. But yeah, to that officer, utilize us, utilize there. We're not the only entity, and this is too big, right? So I'm a big sharer as long as the other organizations are teaching and saying the correct things, right? We're all for the safety of all of us interacting with these vehicles and these systems, and the more collective that we can come together with these other agencies that are researching and that are testing and that are teaching, it's amazing. So vet your resources. There are good resources and there are not so good resources, right? So
if this is from Zach McVicker, if we have an off gassing, it may be potentially going in the direction of an ignition source. Would it be beneficial to spray the smoke with water in order to reduce the volatility?
You may, so yeah, or control the direction of that. You could use hydraulic ventilation by still using your hose, but not necessarily directly spraying the battery pack or the gas by hydraulically ventilating. But if there was an issue and that wasn't working, then yeah, if you need to do something that could work to manage to not create a more serious event, then absolutely. And then your process there may be, what can I do for the initial, but then secondary, let me get this, can I move it from here so that we don't have to keep managing it in this way, right? Can I get it away from that exposure?
So has there been an increase in thermal events at EV charging stations compared to normal operations?
So
he's asking the question because the government in Canada is requiring all these charging stations to be installed.
Right. So I don't have data, but I'll give clarification and then you can input your thoughts here. So, when we're looking at the number of vehicles that are on the roadway, right, that are hybrid or electric that require charging, right, we're exponentially gaining every month, right? When we look at projections, I don't know that we're going to hit the projections that the our current administration has put out, but basically it's what, 2024 now. They were projecting by 2025-ish that there would be about 15 to 18 million hybrid electric vehicles on the roadway. There's a very good chance that we may hit that, by 2030-ish. So let's say in 2034, 10 years from now, the projections were and are 60 to 68% of the vehicles on the roadway would be hybrid electric, right? So I don't know if we'll hit that. But even if we hit 30%, so think about this, if we hit 30% in the next 10 years, there's about 290 million passenger and commercial vehicles on the roadway. So in 10 years, we're going to be over 300 million. So that means if only 30% are hybrid or electric, that's still 100 million, right? So these charging stations are popping up everywhere. So it's still new is what I'm saying is, so it's hard to collect data on events, and there's really nothing on reporting currently that ties into like lithium ion battery fires and things like that. And so I know there's groups trying to work on that for reporting so that we can get better data to do better things. But understand that outside of physical, electrical, thermal abuse, when the vehicle's been in an accident, the second greatest incident of an event is when the vehicles are charging, right? Because I'm purposefully moving electricity through that vehicle and through that system. So I guarantee you the incidence of vehicles while charging is going to exponentially increase as the vehicles are increasing themselves on the roadway, right? And that's not just, that's your commercial chargers, and that's also residential, because your OEMs are going to tell you to not charge your vehicle where? In the garage. But where does everybody charge their vehicle? In the garage, right? So we're going to have, I know just in our local area in central Ohio in the past 2 years, we've had two major residential fires. One burnt the whole house down. Another one created a close call with the firefighters that responded. And both were EVs charging in the garage. So whether it's residential or commercial, yes, when you're moving electricity, if something's wrong with either the charging unit or something's wrong with the vehicle, whether a manufacturing defect or something from an accident or something else, the likelihood of an event is increased because you're moving electricity. So,
okay. Look, we're going to run out of time. So here's what I'm going to say to everybody. If we didn't get to your question, I apologize. But I will make this offer to you. Bobby's email address will be in the email you get tomorrow. I will make sure Sam puts my email address in there as well. If you want to get your questions to me or send them directly to Bobby, we'll get your question answered if we didn't get to it in the Q&A tonight, because some of them are repeats, some of them are new, but we're going to run out of time. We're afraid Zoom's going to shut us down here shortly. So I apologize if we didn't get to your question. All I'm asking you is, if you send a question to me or you send it to Bobby, you'll get an answer to your question. And that's the best we can do. So we're going to move on here and wrap things up. So, Bobby, obviously this was an extremely informative presentation, and we could probably go for another hour without too much difficulty. For our listeners to get additional information about the Energy Security Agency, you can go to www.energysecurityagency.com. And again, that link will be in the emails tomorrow. There will be a short survey at the end of the webinar. We would ask that you take just a few minutes to complete it. You can also check out our Station 1902 podcast episode with Bobby that went live on February the 1st. If you've already subscribed to Station 1902, you should have received an email letting you know a new episode was uploaded. If you're not currently subscribed to our podcast, look out for the link in the post-webinar email we'll send. All you need to do is subscribe, is to input your email address, and you can start listening to our podcast. As we mentioned in the beginning, please join us on March the 26th with Alex Mayer from the Center for Disease Control, National Institute of Occupational Safety and Health, when he'll discuss and show you how easy it is to register for the National Firefighter Cancer Registry. Folks, I'm going to say this before I sign off for tonight. This has been up and running now about 3 years, and we only have 10,000 firefighters in our country registered in the registry. I'm going to probably agitate some people because you think I'm giving you hell, but that's terrible, folks. You don't have to put medical information into the registry. They're going to ask you for some demographics and tell them where you've been, where your assignments have been in the fire service. So if you've been at one station your entire time, it'll take you 30 minutes. If you were like me and in the military and from one air base to another in the Air Force and then as an instructor, it may take you longer. But at the end of the day, it will only help the fire service going forward when it comes to dealing with cancer in the fire service. So there's my editorial. I'm asking you, join us on March the 26th so you can learn more about it. If you need any further information or questions, please email us at info@provident.ins. Thanks to everybody for hanging with us tonight. Again, if you have questions that we haven't answered, send them to me in an email. Sam will give you that link. The other links that you need to be able to get a hold of Bobby will be in the email that you receive tomorrow. And again, thank you for staying with us tonight. We're doing good. So thanks, Bobby. I certainly appreciate your help tonight. Sam helps thank you for your help in the background. Good night, everybody.
Night.